Okay, welcome to another class for today. And today we want to go to a new topic under the first aspect of the quantitative reasoning in GRE. And the first aspect is arithmetics, and that is what we are still looking at. So we've been able to run through the first two topics under arithmetics, that is the number properties and sequence. Now today we want to go through fractions, majorly fractions and decimals, but for today's class we will only run through fractions, and the next class we will look at decimals. Okay, so now what are we going to look at? We are going to talk about fractions and decimals, like I said, in this class and the next one. And under these two, we'll try to run through fractions, arithmetic of fractions, facts about fractions, fractions in words, decimals, facts about decimals, types of decimals, and then rounding of decimals. Okay, so but like I said, today is going to be only on fractions, so we'll be running through the first 4 subtopics. Okay, so now let's get started. Now, what are fractions? Fractions are numbers in the form a over b, where a and b are integers and b is not 0. Okay, so that what we are saying here is that for you to have a fraction, you must have something like this: one number over another number, and the two numbers must be integers, that is whole numbers, and this b must not be 0, because if it is 0, then that is no more a fraction, because that will not be a number. All right, so integer a is called the numerator and b is the denominator. All right, so you call this one on top the numerator, and the one below it you call it the denominator. Now, if a is less than b and a is greater than 0, b is greater than 0, the fraction is called a proper fraction and it is less than 1. Okay, so that means if your numerator is less than the denominator and the two numbers are positive numbers, then that fraction is called a proper fraction, and it is always less than 1. Less than 1. Even if one of them is negative, even if the two of them are negative numbers, they will always be less than 1. Any proper fraction generally is less than 1. Then if a is greater than b and a is positive and b is also positive, then the fraction is called an improper fraction and it is greater than 1. So for improper fraction, the two numbers must be positive before they can be greater than 1. Alright, so your numerator, if it is bigger than the denominator and they are both positive numbers, so the fraction is an improper fraction and is greater than 1. Now if a is equal to b, the fraction is simply equal to 1. Alright, because a will cancel b, then you have 1. Alright, now note, minus a over b is equal to a over minus b, and the same thing as minus a over b. So something like minus 2 over 3 is same thing as 2 over minus 3, and the same thing as minus 2 over 3. So you can take the minus to any of the numbers and you're still going to have the same fraction. Now 2 over 3 is same thing as 2 times 2, which will give us 4. 3 times 2 just give us 6, and the same thing as 2 times 5 just give us 10, and 3 times 5 just give us 15. So now this means 2 over 3 is the same as 4 over 6 and same as 10 over 15. These are called equivalent fractions, because if you cut these 2 down and this 4 over 6 down by divide each of these numbers by 2, you are going to have 2 over 3. If you divide this 10 over 15, you divide each number by 5, you still have 2 over 3. So it means these 3 fractions are the same. They are called equivalent fractions. So one thing you must understand is that if you multiply the numerator and denominator by the same number, you will produce a fraction that is equal to that same fraction. Alright? If you multiply the numerator and the denominator by the same number, you are going to produce a fraction that will still be the same as that initial fraction. And same way, if you divide a fraction, the numerator and denominator, by the same number, you produce a fraction like 2 over 3 now, that will be the same as this same old fraction. Okay, so multiplying or dividing the numerator and denominator by the same number still keeps that fraction the same. It doesn't change the fraction, so you still are going to have the same equivalent fraction. All right, so now we have arithmetic of fractions. That's addition and subtraction of fractions. Now, when we want to add or subtract fractions, what do? Simple thing we need to do is to find the LCM of the denominators. The LCM, the lowest common multiple of the denominators, that is the smallest number that the denominators can divide. So, for example, here we have 2 over 5 plus 1 over 5. Now, here, because the denominators are the same, they are both 5. The LCM will still be same 5. So when you have this kind of fraction, you don't need to stress yourself. Just whatever if the denominators are the same thing, the LCM will be that same denominator, and therefore, so it will mean you have 2 plus 1 as a numerator, which will give us 3 over 5. So when you have a fraction like this, you'll be able to do it straight up without wasting your time. All right. So once you see this, you just say 2 plus 1. So answer will be 3 over 5. That's all. Now, if I look at example 2, 1 over 2 minus 3 over 10. 1 over 2 minus 3 over 10. Now, here, the denominators are not the same. This is 2, this is 10. So we need to find the LCM of 2 and 10. That is the smallest number that you know that 2 will divide and 10 will also divide. Alright, so if you can't think of the number, you can probably just do the number LCM. That's doing the table thing that we discussed in the first class, I think. Alright, so that will be the LCM. And if you don't want to do the table to get your LCM, another strategy you can use to get your LCM is look at those denominators and look for the biggest of them. Alright, the biggest. So like in this case now, I have 2 and 10. The biggest is 10. Then write some multiples of 10, like maybe the first 4, first 5. Alright, and check among those first 4, first 5, which of them, I mean the first one that you know that the other denominators can also divide. Then that must be the LCM. So if I write multiples of 10 here, I'm going to have 10, 20, 30, 40, 50, and so on. So automatically here, 10 is the first number among those multiples that I know that 2 will go in. So definitely the LCM will be 10. Okay, so that now here it means my LCM will be 10. So now I'm going to have 2 in 10. I have 5. So that will be 5 times 1. So I have here. Alright, then 10 in 10 is 1. 1 times 3. That's what I have here. So meaning 1 times 5 is 5. 3 times 1 is 3 over 10. That's 5 minus 3 should be 2 over 10. Then I have 1 over 5. That's 2 here, 1, 2 here, 5. So that way we can simply find or subtract these two fractions. Alright, so that's how we can simply subtract our fractions or add fractions, find the LCM. Okay, so when you are carrying out this kind of thing, you can, it's all about the denominator, how you get the LCM to be able to add or subtract those fractions. Now, doing the LCM faster is one key thing you must learn to do here. So I already give a tip. Alright, let me just take another example with different denominators so that you can see how you can do the LCM in a faster way. Okay, so let's look at this simple example here. Let's say we have 1 over 5 plus 2 over 3 minus 3 over 10. Alright, over 10 is equal to what? Okay, so now looking at 5, 3, and 10, I want to think about the LCM, the smallest number that I know. 5 can divide, 3 can also divide, 10 can also divide. Okay, now that means I need to get my LCM of 5, 3, and 10. So what can I do here to do my LCM faster? Like I said, I will pick the biggest of them, and which is 10. And now I will just write some multiples of 10, and that means multiples of 10, that's 10, 20, 30, 40, 50. Now, among these numbers here, as you can see, which is the first one you know that 5 can divide, 3 can divide, 10 can also divide? Is it 10? No, because 3 cannot go in 10. Is it 20? No, because 3 cannot go in 20. Is it 30? Maybe, I think, because 5 will divide, 3 will divide 30, 10 also divide 30. So the LCM will be 30. Alright, so quickly we then have 30 as our LCM. So that means 5 in 30, we have 6, 6 times 1, then we have 6, plus 3 in 30, we have 10, 10 times 2, we have 20, minus 10 in 30, we have 3, so 3 times 3, we have 9. So this gives us 26 minus 9 over 30. And that will give us what? 17 all over 30 as the simple way to find that. Okay, now let me show us another method that I can use here to make the work faster. For instance, let's say we have 3 over 4 plus 8 over 15. Okay, so here I'm looking at 4 and 15 and my LCM. So if probably I'm thinking of taking my LCM will be a difficult something, then there's one thing I can do, and that thing is to make these denominators the same. This is cool if you have two fractions like this. Alright, and what I would do is just that I'll multiply this one by 15, multiply this one by 4, and I'll make them equal. Okay, because I know once the denominators are the same, the LCM will be that same denominator. Okay, so whatever I do to 4, I must do to 3, and whatever I do to 15, I must do to 8. So that means I'm going to have, so if I multiply by 4 by 15, then I must multiply 3 by 15. Same, if I'm multiplying my 15 by 4, I must multiply 8 by 4. So this gives me 45 over 60 plus 32 over 60. So now that the two fractions have the same denominator, as you can see, then the LCM will be that same denominator, 60. And I will have 45 plus 32. And that will give me 77 over 60 as my answer. So in a way, it saved me from thinking of LCM. So this idea is cool if we have two fractions like this and you want to add or subtract them. Okay, so we can use all those short ideas to quickly add or subtract our fractions. Alright, now we have multiplication of fractions. Alright, so when we want to multiply two fractions, how do we go about that? Now when you're multiplying fractions, you don't find the LCM of the denominators. No, you don't do that. All you need to do is divide the fractions, that is simplify them and multiply out. Okay, so you pick one numerator and one denominator and divide by a common factor that you know, a number you know can divide the two of them. Alright, so in this example, as you can see here, I can pick this numerator and this denominator, or maybe this one and this one, if I see a number that I can divide it to, or this and this. So not two denominators or two numerators, one numerator, one denominator. Then you can divide with a common factor. So here in this example, we have 25 over 63 times 21 over 50. So here, I can see 25 and 50. That 25 can divide the two of them. So I can then go straight by using 25. So 25 and 25 will give me 1. 25 and 50 will give me 2. Okay, then I can see 63 and 21, that something can divide them, which is 21 itself. So 21 and 21 is 1, and 21 and 63 will give me 3. Therefore, this means I have 1 times 1 over 3 times 2, which will give me 1 over 6. So I'll simply multiply these two fractions. Alright, if you can't think of big numbers like 25, you can start with 5, because you know that any number that ends with 5 and 0, 5 will divide it. That's from our divisibility rules. You can check that from the third video, I think. Alright, so that will give us 1 over 6 as our answer here. So that's how we simply multiply two fractions. Alright, even if we have more, if we have 3 or 4, same thing, just keep dividing. So you are able to multiply them out. Okay, then we have reciprocals of fractions. The reciprocal of a fraction is the multiplicative inverse of the fraction. And what do you mean by multiplicative inverse? You're talking about a number that will multiply another number to make that another number 1, to turn it to 1. That's what by multiplicative inverse. Okay, multiplicative inverse. So the multiplicative inverse of a fraction is its reciprocal. So the multiplicative inverse is the same as the reciprocal of a fraction. So for instance, if I have 2 over 5, the reciprocal of 2 over 5 it means 1 over 2 over 5, and it simply turns to 5 over 2. So when you are writing reciprocal, simply turn the fraction upside down. The numerator becomes the denominator denominator becomes the numerator, just something like that. That's what I'm trying to say. So not that just turn it like it's constant with that thing. No, the numerator turns to the denominator becomes the numerator. Okay, so that's what will give you the reciprocal. So this reciprocal is multiplicative inverse of this number, because when you multiply the 2 over 5 times 5 over 2, 5 will eliminate 5, that's 5 divided by 5, we have 1, 2 divided by 2, we have 1, and that will give us 1 at the end of the day. So that's why it is the multiplicative inverse, because since we use this to multiply this and we get 1, then this number is multiplicative inverse of this number, and this one is multiplicative inverse of this number. So therefore 5 over 2 is the reciprocal of 2 over 5, and also 2 over 5 is the reciprocal of 5 over 2. So the product of a fraction and its reciprocal is always equal to 1. That's fact. So when you multiply a fraction and its reciprocal, you will always get 1. You will always get 1. Okay, so we have division of fractions. Now to divide a fraction by another fraction, simply multiply the numerator fraction by the reciprocal of the denominator fraction. So we are saying here, how do we divide two fractions? Simple. All we need to do is first the fraction after the division sign. That's what we call the denominator fraction. Alright, this fraction here, simply turn it to its reciprocal. So as it is now, it is 50 over 21, so its reciprocal will be 21 over 50. And once you do that, this division sign turns to multiplication sign. So here I have 24 over 63 divided by 50 over 21. So that means it will now have, it will be 25 over 63 times 21 over 50. Okay, so you cannot do anything until you turn this division sign to multiplication. And once you do that, this 50 over 21 turns to its reciprocal, which is 21 over 50. And so now we can see 21 here 1, in 63 we have 3, and 25 here 1, and in 50 we have 2. So at the end of the day we have 1 times 1 over 3 times 2, which will give us 1 over 6. So we have simply divided this fraction by this fraction, and this is the result. Okay, so that is how we divide two fractions. Okay, now we have facts about fractions. Number 1, if the numerator of a fraction is 0, the fraction is equal to 0. That is, 0 divided by anything is 0. So once you see numerator as 0, just know that the result is 0. There's no need to waste your time. Alright, so what I'm saying is, for instance, 0 divided by 5 is equal to 0. That's it. 0 divided by 27 is equal to 0. 0 divided by A is equal to 0. 0 divided by U is equal to 0. Alright, so the only difference is that 0 divided by 0, that has no solution. It's undefined. Alright, undefined, because 0 cannot divide itself. So that's the only difference. Well, others, even 0 divided by a negative number will still be 0. Alright, so that is what that point is saying. So when your numerator is 0, the result is 0. Okay? Now 2, if the denominator of a fraction is 0, the fraction is undefined. Okay? If the denominator of a fraction is 0, the fraction is undefined. That is, anything divided by 0 has no solution. Anything divided by 0 has no solution. So, for example, 5 divided by 0 is undefined. It's infinity. No solution. No solution. No answer. Okay? Anything 7 divided by 0, no solution. 8 divided by 0, no solution. Alright, that's why 0 divided by 0 is also no solution. So, when you are having 0 as your denominator, there is no answer. Alright, it is undefined. So, 3. If a set of fractions has the same numerators, then the higher the denominator, the lower the value of the fraction. Do you get that? If a set of fractions has the same numerators, then the higher the denominator, the lower the value of the fraction. So what we are saying is that if you have a set of fractions that have the same numerator and you want to compare, they want to know which one is bigger or smaller, all you need to do is to check their denominators. The one with the bigger denominator will be the smaller fraction. Do you get that? So once the numerators are the same, just check the denominator. The one with the bigger denominator will be the smaller fraction. So here 7 over 6 is less than 7 over 5. Yes, because 6 is bigger than 5. So this fraction will be smaller. to be smaller. You are dividing something by a bigger number, so you are going to get the smaller result. Okay, so 7 over 5 is less than 7 over 4, 7 over 4 is less than 7 over 3, 7 over 3 is less than 7 over 2, and so on like that. So if we have the same numerator, the bigger the denominator, the smaller the fraction. The next one says if a set of fractions has the same denominator, then the higher the numerator, the higher the value of the fraction. Alright, here we're looking at the same denominator. Alright, like you see here, 7, 7, 7, 7. So now, if we want to compare, we check the numerator. The bigger the numerator, the bigger the fraction. The bigger the numerator, the bigger the fraction. So here, 2 over 7 is less than 3 over 7 because the numerator is bigger than this. Alright, 2 over 7 is less than 3 over 7. 3 over 7 is less than 4 over 7. 4 over 7 is less than 5 over 7. 5 is less than 6 over 7. Alright, so these 2 points here, you can use them to compare two fractions. Alright, for example, let's say we have a simple question like this. Quantity A, 7 over 12. Quantity B, 4 over 9. Okay, so now if you want to compare these two fractions, we can apply that one of those methods, one of those 2 points. Either we can make the two denominators equal and then compare the numerators, or we can make the numerators equal and compare the denominators. So anyone will help you to compare these two fractions. Okay, so for instance, let me say that I want to make the numerators equal. Okay, I want to make the numerators equal. So if I want to make the numerators equal, I have 7 over 12 here, and this one is 4 over 9. Now, if I want to make the numerators equal, all I need to do is multiply this 7 by this 4, and multiply this 4 by this 7. Okay, so this becomes 7 times 4. And whatever I do to the numerator, I must do to the denominator. So this also becomes 12 times 4. And here, this will be 4 times 7. And this will also be 9 times 7. Now, this gives me 28 over 48. And this is 28 over 63. Okay, so now I have been able to make their numerators the same. And remember, if the numerators are equal, then the bigger the denominator, the smaller the fraction. So here now, the bigger denominator is 63. 63 is bigger. Alright? So now, since 63 is bigger, it means that 28 over 63 is smaller than 28 over 48. Or, what's our 28 over 63? That is 4 over 9. 4 over 9 is less than 7 over 12. So, now, you can decide to use the second point to compare these fractions as well. That is, by making their denominators equal and then comparing their numerators. Okay, let me just give you another idea how you can compare two fractions, 7 over 12 and 4 over 9. Now, another thing you can do here is just do a simple cross multiplication. Alright, cross multiplication. That is here, for instance, now we have 7 times 9. So I will multiply this and write my answer here. Alright, so 7 times 9 will be 63. Okay, then 12 times 4 will give me 48. Now, since 63, as you can see here, is greater than 48, then it means 7 over 12 is greater than 4 over 9, or 4 over 9 is less than 7 over 12. So another method you can use to compare two fractions. Alright, so another kind of question you can solve with those 2 points is this. For instance, question can say arrange 1 over 2, 1 over 3, 2 over 3, 4 over 5, 1 over 6 in ascending order. Okay, arrange all these fractions in ascending order. Alright, so now as you can see here, you can decide to like probably turn the fractions to decimals and then compare the decimals. Okay, but if you don't want to do that, another thing you can do is to try and see if you can make their denominators the same. Alright, if you can make their denominators the same. And what does that mean? Simply get the LCM of the denominators. LCM of the denominators. And if you do that, now the LCM of these denominators will be 30. The smallest number they all can be 2, 3, 5, and 6. Like I told you, you can just pick the biggest is 6, write multiples of 6, and see the one that the first that all these numbers will divide. Okay, so if you do that, we have 30. Now we have 2 in 30, which will be 15. So 15 times 1 will give us 15. Then we have 3 in 30, which will give us 10. So 10 times 1, we have 10. 3 in 30 will give us 10 again. 10 times 2, we have 20. Then 5 in 30, we have 6. 6 times 4, we have 24. Then 6 in 30, we have 5. 5 times 1, we have 5. So as you can see here, this simply means 15 over 30. That's my 1 over 2. 10 over 30, that's my 1 over 3. 20 over 30, that's my 2 over 3. 24 over 30, that's my 4 over 5. Alright, so 5 over 30, that's my 1 over 6. Now, it means they now all have the same denominator. Now, I can compare their numerators. And remember, when you have the same denominator, the higher the numerator, the higher the fraction. Or the smaller the numerator, the smaller the fraction. So here, the smallest numerator here is 5. And that is 1 over 6. That means 1 over 6 is the smallest. Remember, we are arranging in ascending order. That's from the lowest to the highest. After 5, the next is 10, which is 1 over 3. Then the next is 15, which is 1 over 2. And the next is 20, alright, which is 2 over 3. And the next is 24, which is 4 over 5. So we have been able to arrange these fractions in ascending order. 1 over 6, 1 over 3, 1 over 2, 2 over 3, and then 4 over 5. So that's another way we can apply that one of those 2 points to arrange fractions. Moving on. So the next point says 1 over x plus 1 over y is equal to x plus y over x minus y. Alright, so we do this to make our work faster in a way when you are adding fractions. So if you see 1 over something plus 1 over something, it simply means addition of the denominators divided by multiplication of the denominators. Okay, the same thing when you have subtraction, it simply means the difference in the denominators divided by multiplication of the denominators. So 1 over x minus 1 over y is equal to y minus x over x times y, or y times x, anyone, you still get the same thing. So what we are saying here is this. For example, if you have 1 over 2 plus 1 over 3, this same thing as 2 plus 3 over 2 times 3, which is going to be 5 over 6. Alright, very fast. So you will not need to bother yourself thinking of LCM for these 2 numbers, but you must ensure you have 1 as a numerator. That's the key thing for this rule. Okay, so if I have 1 over 7, maybe plus 1 over 12, this same thing as 7 plus 12 over 7 times 12, which will give me what? I have 19 over 84. That is the addition. Okay, so it makes the work faster. Okay, so if I have 1 over 5 minus maybe 1 over 10, okay, this same thing as 10 minus 5 over 10 times 5. So which will give me 5 over 50. I can cut it down, giving me 1 over 10. Okay, so no matter what you have, if you have 1 over 2 minus 1 over 3, so that is 3 minus 2 over 3 times 2 to give you 1 over 6. So we can simply use those short points to get this kind of fractions faster without wasting our time. Okay. So we can also note these simple fractions here just to know we are looking at how to do our work faster. Like I've always said, GRE is all about how fast you can do it. There's no time to be doing long mathematics. So we are looking at short ways you can do things to make your work faster. So 1 minus 1 over 3 is something as 2 over 3. Okay, because 1 can be written as 3 over 3. So similar like saying 3 minus 1, which will give you 2 over 3. So just straight away, so when you see that, just know that to be this. Or another thing you can just do in a way, just do 3 minus 1. That's what be, so your answer with the numerator, that's 2 over 3. Same thing here, as you can see here. Now we have here, this is 2, which is 2 minus 1 over 5. Now 2 can be written as 10 over 5. So all you need to do is to think of how you can write this integer, this whole number, as something over this denominator. So that when they have the same denominator, just add or subtract the numerators, and that's all. Okay, so 2 minus 1 over 5 is 9 over 5 because 2 is something as 10 over 5. And 10 minus 1 is 9 over 5. Same thing if you have addition. 3 plus 2 over 5. As you can see here, I can write my 3 as 15 over 5. And that will be 15 plus 2, which will be 17 over 5. And that's 3 whole number, 2 over 5. So one thing about addition is that even if you see like they just remove the plus, the answer will be 3 over 3 whole number 2 over 5. Yes, just remove the plus. But for minus, you may have to do this to get the answer. But for addition, just remove the plus. That's 3 whole number 2 over 5. So it is 1 plus 2 over 5 to be 1 whole number 2 over 5. Okay, so that's how you can simply add your fractions or subtract. So those simple fractions. And in GRE, we don't get to see too big fractions. So if you know your key ideas, you have all these key ideas, all these short points, you can see to simplify your fractions easily and you won't waste your time. Okay, we have fractions in words. So sometimes you can see your fractions in words. So when you express in words, you understand what they are saying. So this first one says a half. So when you say 1 over 2, it means a half, or you can call it 1 half. So when they say a half or 1 half, it means 1 over 2. All right, 1 over 4 is 1 quarter, as you know. 3 over 4 is 3 quarters, 3 of a quarter. So that's 3 quarters. 2 over 3, that's 2 thirds. 2 of thirds. So 2 thirds. 6 over 7 is 6 sevenths. 4 over 9 is 4 ninths in word. 5 over 16 is 5 sixteenths. 1 whole number 1 over 2 is 1 and a half. So try to see the difference between this and this. So if you see a half or 1 half, that's 1 over 2. But when you see 1 and a half, that's 1 whole number 1 over 2. So try to note the difference. Okay, now let's look at these examples just to wrap up the class quickly. Now, example 1 says, of the following, which is least? Of the following, which is least? Now, if you check these options you have, 0.03 over 0.00071, 0.03 over 0.0071, 0.03 over 0.071, 0.03 over 0.71, 0.03 over 7.1. Now you see that all these options, all these fractions have the same numerator, the same numerator. This is a real exam question, so try to understand what I'm saying here. The same numerator. So now, if they have the same numerator, remember that point, then the bigger the denominator, the smaller the fraction. The bigger the denominator, the smaller the fraction. So for me to make this work faster, all I need to do is to check my denominator. Which one is the biggest? So the biggest one, the one with the biggest denominator must be the smallest or the least fraction here. And if you check all these denominators, it is obvious 7.1 is the biggest. Therefore, this option E, 0.03 over 7.1, is the least fraction among these 5. So our answer will be E, option E. Alright, cool. I believe that's cleared. Now let's look at number 2. It says 1 over 3 plus 1 over 2 minus 5 over 6 plus 1 over 5 plus 1 over 4 minus 9 over 20 is equal to what? Okay, now we have additions and subtractions of several fractions here and all that. And you'll be thinking, okay, that means you have to find the LCM of 3, 2, 6, 5, 4, 20 and all that. Yeah, you can do that. Find the LCM, do the normal thing, get your answer. You will get the right answer, fine. But the question is how long? How long? If it's just taking you 2-3 minutes in GRE, that is becoming too long. Yes, you have to make sure you set everything within 1 minute, 1.5 minutes, or probably maximum 2 minutes if you have some hard or tough questions. Okay, so how can we do this in a faster way? Now, let's look at the question. So, the question says 1 over 3 plus 1 over 2 minus 5 over 6, but plus 1 over 5 plus 1 over 4 minus 9 over 20 is equal to what? Now, like I said, you can do your LCM thing and all that, fine. But if I were you, I would notice something here. And what is that? Look, these two fractions, can you see that? And these two fractions. Can you remember anything about those two fractions? Yes, you should now. Alright? And what is the thing? Remember, if you have 1 over something plus 1 over something, simply be the multiplication of addition of denominators divided by multiplication of the denominators. So this 1 over 3 plus 1 over 2 will simply be 3 plus 2, which will be 5, over 3 times 2, which will be 6. That's all. Then minus 5 over 6 plus, also here we will have 5 plus 4, which will be 9, over 5 times 4, which will be 20. Minus 9 over 20. What can you see here? 5 over 6 minus 5 over 6, 0. 9 over 20 minus 9 over 20, 0. 0 plus 0, 0. So our answer is 0. Can you see? So that's how we can apply that to make our work faster. As you can see, it's very fast. Within 30 seconds, you can solve this and you are done. Of course. So if you remember these ideas, they make the work faster. Okay, so that is one thing we have to understand here. And that's how we solve this question. Alright? So our answer is A. The result is 0. Okay, so now let's say this last one. This is a word problem question on fractions. So this is if of the goose eggs laid at a certain point, 2 over 3 hatched. 2 over 3 hatched, and 3 over 4 of the geese that hatched from those eggs survived the first month. Of the geese that survived the first month, 3 over 5 did not survive the first year. If 120 geese survived the first year, and if no more than 1 goose hatched from each egg, how many goose eggs were laid at the pond? Okay, it's a long question. Yes, it's a word problem question. But all you need to do is just take your time, alright? You have to analyze the questions line by line. You don't rush when you're taking a word problem question like this. Just take the statement line by line, express them with some mathematical terms like maybe a variable or numbers, and then at the end of you see what you have and I can put them together. Okay, now how do we solve this? Let's check. It says of the goose laid at a certain pond, 2 over 3 hatched. So there are some eggs laid and we don't know their number. And as a matter of fact, that's what the question is asking, how many goose eggs were laid. So we would definitely need to represent the number of eggs laid by something. Usually we use x, as you know in mathematics. So for instance, we say number of eggs laid, let's say x. Okay, number of eggs laid, x. Okay, now the question says of the goose eggs laid at a certain point, that's of the eggs, 2/3 hatched. 2/3 hatched. So what does that mean? It means hatched. Let me put it that way. Hatched. That means 2/3 of x. So that was 2 over 3 x. Alright? 2 over 3 x. Okay, let's continue. So the question continues and says 3 over 4 and 3 over 4 of the geese that hatched from those eggs survived the first month. That is 3 over 4 of the 2/3 that hatched. Only 3 over 4 of them survived the first month. So let's see how we express that in terms of the x. So let me put it like this. Survived the first month, or first month survivors, that will be 3 over 4 of means times the hatched eggs, 2/3 over 2 over 3 x. So 3 eliminates 3, then 2 here, 1 here, 2. You can always simplify that like that so that you can have simple fractions to work with. So that gives me 1 over 2x. So survived the first month. Okay, you can say we're taking it line by line. That's how you answer word problem questions. Now let's continue. Now, of the geese that survived the first month, can you see that? Of the geese that survived the first month, 3 over 5 did not survive the first year. Of the geese that survived the first month, 3 over 5 did not survive the first year. So what does that mean in terms of our x? It means, so of this half x that survived the first month, now 3 over 5 did not survive the first year. So let me put it like this: did not survive the first year. That's 3 over 5 of half of x. Okay, 3 over 5 of half of x. And one thing I will just try to do here is I will try to find, okay, survived the first year. Survived the first year. Okay, so if 3 over 5 did not survive the first year, that means 2 over 5 survived the first year, because that means total will be 1. So we are going to have 1 minus 3 over 5. 1 minus 3 over 5. If you remember the short method, that will give us 2 over 5. Okay, that's 5 over 5. So 5 minus 3. So we have 2 over 5. So that means if 3 over 5 did not survive, then 2 over 5 survived. So that means survive the first year will be 2 over 5 of half x. So now if I simplify this one, let me do this now. I'm going to have 3 over 10x. And if I simplify this one, as you can see here, this will be giving me, I'm going to have 1 over 5x. Okay, so now let's continue, because one fact is that we'll definitely probably either going to need this one or this one to finish the problem. So that's why I've decided to find survive the first year, even though the question has not mentioned it. All right, sometimes you do that, probably you may need it. Okay, now if 120 geese survived the first year, okay, now you can see survived the first year. Definitely we are going to need survived the first year. So if 120 geese survived the first year, and if no more than 1 goose hatched from each egg, how many goose eggs were laid at the pond? So they are telling us that 120 geese survived the first year. Now in this kind of question, we are already given a number. You know, everything has been fraction, 2 over 3, 3 over 4, 3 over 5, cool. But now we are given a number. So when we are given a number like this, well, it is possible they now ask you a number or a fraction again. So there can be another kind of question like this where only fractions will mention all through, no number mentioned. And in the question, they will be asking you a fraction again. They can say, what fraction of? So they're asking you one fraction of, they're asking you a percent, or they're asking you a ratio or something. In those kind of questions, you can choose a number for your total instead of using x. You may decide to use total, maybe 100, maybe 200, maybe 1000 for your total number. So you will not be working with x. You're just working with numbers, and that will be that. But that is if no number like this is given. If everything is just fraction, and they're also asking you fractions, okay, or they're asking you a percent, or they're asking you a ratio. But once a number is given like this, you cannot choose a number again. You must use a variable to represent anything you need to represent. Okay, so let's continue with this. So now 120 geese survived the first year. So what does that mean? Survived the first year is equal to 120 geese. So from our calculation now, it means 120 geese survived the first year. Survived the first year. Can you see? You can see now that that's what they want us to use. So, and the fraction is 1 over 5. So it means 1 over 5 of total is equal to 120. Those are survived the first year. Therefore here, we can say over 1, I will cross multiply, meaning x times 1 is equal to 5 times 120. Therefore, our x is equal to what? 600. That means a total of 600 eggs were laid. Alright, so that is the answer to this question. So we have 600 as total eggs laid. So as you can see, this is how we answer a word problem question, though because it involves fractions, we are beginning to under fractions. We'll still look at word problem this later. But you take it line by line, just analyze, and at the end of the day, you'll be able to arrive at your answer. Okay, so that's brings us to the end of today's class. We have been able to run through fractions and everything you need to know about fractions. So I would advise that you go through the video again, look at the examples again, and then search for more questions to practice, and that will make you better. All right, so this is where we end the class today. So in the next class, we'll look at the second part of this fraction and decimals, which is the decimals that I'll be looking at in the next class. And ensure you don't miss the class. See you there. Bye.